Problem 19. A car has an engine which delivers a constant power. It accelerates from rest at time t equals 0, and at time t equals t0 its acceleration is a0. What is its acceleration at time equal to t0? Ignore any loss due to friction. So first of all, let's write the expression for power. We know that power equal to applied force multiplied by speed, which means that for a regular car that will be mass multiplied by acceleration and by speed. From other hand, we know that if we don't lose any power, all power going to kinetic energy, because we have constant power, our kinetic energy increases linearly. So this is the expression for kinetic energy. This expression is good for time equal t0. If we have time equal to t0, we have to double our kinetic energy, which is this one. And from here we can immediately say speed equal root 2 v0. This is how our speed increases with time. And now, if we look at this expression, if we increase v in root 2 times, it means that our acceleration will decrease on the same value. So finally we have acceleration a equal 1 over root 2 a0. This is the B answer. Problem number 20. The Young's modulus E of a material measures how stiff it is. The larger the value of E, the more stiff the material. Consider a solid rectangular steel beam which is anchored horizontally to the wall at one end and allowed to deflect under its own weight. The beam has a length L, vertical thickness h, width w, mass density ρ, and the Young's modulus E. The acceleration due to gravity is g. What is the distance through which the other end moves? Beam sagging. Hint: you are expected to solve this problem by eliminating implausible answers. All of the choices are dimensionally correct. Solution. Usually such problems in US Olympia, they are connected to dimensional analysis, but here they already told that dimensions are all correct, so we just need to make quality analysis, which parameters has what kind of influence on this deflecting. Let's start with this table. We will check for each parameter how it will affect this deflection and exclude what can we exclude. So first of all, Young modulus, it's how stiff it is. It means that how difficult under the gravity, for example, to compress or to stretch our beam. So let's see, first A. If we increase E, this expression decreased, so that's possibility. We can mention it here. A. Next one is B. Same thing, we increase E, deflection decreasing, so B is correct. C is not correct because it's not including E, but it must, so C is no good. D, same thing, D is good because for same reason we will increase E deflection decreasing. D and E, no good. We increase E and deflection increasing, which is not correct. Let's talk about L, parameter L. If we enlarge parameter L, for sure this deflection will increase. So this is good for choice A. For choice B, for choice C, for choice D, and for choice E. Oh, I'm sorry, it's not including in B, so B is no good. Let's talk about parameter H, height. If we increase H, we increase vertical thickness. It means that this deflection will decrease. A is no good. B is no good. C is no good. Only D and E good. D and E. W is not included, and it obviously has no influence. And rho G, let's check rho G. Rho G, if we increase rho and G, deflection will increase. So it means that A is good, B is good, C no good, D good, and E is not good. So analyzing all these answers, we can see that only D is correct. It's included in all of them. So D is correct answer. Problem number 21. Consider a particle at rest which may decay into 2 daughter particles or into 3 daughter particles. Which of the following is true in the 2-body case but false in the 3-body case? There are no external forces. A. Velocity vectors of the daughter particle must lie in a single plane. For 2 particles cases, of course we have, this is true, because both velocities, they lie in a single line due to momentum conservation. For 3 particles, suppose that 2 particles lie in one plane and the 3rd particle momentum do not belong this plane. It means that we have some part of momentum which not belong to this plane. It means that total momentum is not 0, which is not correct. So it means that all 3 vectors must belong to one plane. It means that A is not correct answer. B. Given a total kinetic energy of the system and the mass of each daughter particle, it is possible to determine the speed of each daughter particles. Let's see. For 2 particles, we have these 2 equations. We have total kinetic energy and we have 0 momentum, and we have both masses. It means that we have 2 variables, V1 and V2, and 2 equations. So it means that that's correct. We can calculate what is speed of each particle. But consider 3 particles cases. Now we have one equation for energy and 3 equations for momentum, because it's vector form in 3D. But we have for each velocity we have 3 dimensions, so we have 9 dimensions for velocities and only 2 equations, so it's not solvable. It's no good. It means that B is correct answer. Let's examine C. Given the speeds of all but one dotted particle, it is possible to determine the speed of the remaining particle. It's not correct, because if we have speed of one particle and we don't know what are masses, so it means that we cannot use this momentum, zero momentum, to determine what is the speed of other particle. And same thing for 3 particles. Again, if we have a speed of one particle and speed of other particle and we don't have any masses, we cannot calculate third speed. And D, the total momentum of the dotted particles is 0. Of course, that's correct for a case of 2 particles and for 3 particles. So it means that it's not good answer. So good answer, remaining good answer is B.